presentations for you this morning. The first one up is from DILO, titled SF6 Gas, the 3R's and Reconditioning. Making the presentation is Billy Lau. Billy is the general manager and CEO of DILO, and the company specializes in SF6 gas and SF6 gas alternatives, handling equipment, services, and gas supply for North America. The company has more than 70 years of experience supplying the power and utility industry tools and materials. So would you please help me in welcoming Billy? And Billy, if you'd share your screen, we'll start.
All right, thank you very much. Appreciate the introduction. We're very pleased to be part of this forum, and we look forward to hearing any feedback on any of the presentations that are given. Thank you again. Again, my name is Billy Lau. I'm the GM and CEO of DILO Company Inc. and DILO Direct. We do specialize in SF6, and my presentation is specifically on certified SF6 gas, the 3R's, and reconditioning versus virgin SF6 gas. So a little bit about my overview. I'm going to definitely hit on some history of SF6. Going to hit some safety items. We're going to dig into what the 3R's means. We're going to discuss reconditioning. I'm going to present also a case study that was given back in the early 2000s at an EPA conference that ties right in with what we're talking about. And at the end, we'll just close out with some conclusions. A little bit about the history of SF6 gas. Discovered in 1901 by French chemists Henry Moissan and Paul Lebeau. They were chemists who specialized in fluorines, and they discovered SF6 gases. They were in the middle of developing a gas that could help them as a deterrent for their furnace. And you see in the picture below, that's actually Henry Moissan running his furnace. So how is it manufactured? Well, it's a pretty involved process. It's an electrolysis process. A number of byproducts are created as a result of the production of SF6, which is very important to take in, because SF6, unfortunately, is the worst greenhouse gas discovered by man, but nonetheless, it's an excellent arcing deterrent and insulator. However, during the process, the contaminants are removed by means of a water and alkali solution wash. They use a number of filtration and cryogenic process means. They scrub the contaminants from the finished product before they put it back into the cylinders for the refining process. And approximately about 10,000 tons of gas, SF6, is produced each year and developed and delivered into North America. So like I mentioned, in the early 1900s, when they found or invented SF6 gas, but it wasn't until 1937 where it was actually discovered that it possessed a much higher dielectric than air, and it actually led into being used widely in the electrical industry. SF6 gas throughout the years, and it was also used as an insulator, as a tracer gas. Many years ago, you could hear that Nike used them in their Jordans, Air Jordans, to kind of pump up their soles a little bit and things like that. But as SF6 is moving on, and again, because I mentioned of the greenhouse gas or the global warming potential, we are definitely moving into alternatives. However, there are great ways of reducing and limiting emissions to the atmosphere, and that's what we're going to discuss here a little further. One of my favorite pictures when I talk about the history of breakers and SF6 gas. This is actually a pickle breaker. It was known as a pickle barrel breaker, excuse me. And the reason was, as you can see, is two pickle barrels. And that T that you see there is actually the contacts, and there's a rope that hangs down. And an individual would stand below that and literally pull the rope down, and that would open the contacts, and oil inside those barrels would be the dielectric or the arcing deterrent. Not a very safe way of doing things, but that's how it was back in the day. Which led us right into safety. So basically, SF6 is not toxic. It's not explosive, of course. It is an asphyxiant, so it displaces air because it's 5 times heavier than air. It does begin to decompose at temperatures at 350 degrees Fahrenheit or greater. Normally because of breaker operations, if you're welding around SF6 or running engines or heaters, smoking, back in the day, you know, having a cigarette in your mouth while handling SF6, and if you had any leaks, you could actually break down SF6 as you're smoking and draw it in. But however, it does regenerate when it cools down. So as you can see through the pictures, if you start at the very top at the 12 o'clock position, the molecule is completely assembled. Once it begins its process to absorb the energy of an arc, it breaks apart. The elements break apart, and then once that arc is extinguished and the energy is removed, it begins to recombine. So SF6 does recombine, and that's what makes it such a great electrical dielectric and arcing deterrent. Again, because I mentioned of it being 5 times heavier than air, something really important to consider is having room monitors or some type of SF6 monitoring system that lets you know if there is a leak. Not only for the fact that you can monitor then if there's an emission, but also if it's an enclosed space like vaults or GIS stations. You can then have a safety factor in there that if you get to one point of alarm or another point of evacuation, you can deal with it. Let's say an SF6 breaker that has a massive failure, blows out the PRD, the pressure relief device. You'd have a massive exhaust of SF6 into an enclosed space. The room monitor would then pick that up and alarm out, and then from there on, you can take some safety precautions. You can read more about it on the NIOSH website, which I included here on this slide. Some other basic safety things to know: special training for handling arc gas is definitely recommended. There are toxic and acidic corrosive components of the gas byproducts, not SF6 gas, but the byproducts themselves. So really important to understand how to deal with that. If an individual is exposed to any of those toxic or corrosive or acidic components, immediately remove them from the contamination, get them to clean air and ventilation, and you're going to treat them for acid vapor. So if you were to call 911, for example, and speak to the EMTs, you're going to let them know, hey, this individual has been affected by acidic vapor. If you mention SF6 gas, they're not going to know that. It's just important to say that, to make sure that you clarify that. And many of the existing standards like IEEE, ANSI, IEC, and SIGRE, they're safeguards. They have processes in place or written guides on how to handle SF6 properly. So here what we have is a guide that was put out by SIGRE, and essentially what it does is it shows you how to deal with gas. So essentially, if you're dealing with virgin or non-ART SF6 gas, you know, you have the option of having to wear a Tyvek suit or gloves, but definitely always wear safety glasses. Definitely, you know, we do recommend gloves just because you're handling fittings and things like that. But when you get into normally ART or heavily ART SF6 gas, where there can definitely be some components of byproduct, and if you're going into a GIE, a gas insulated piece of equipment, you definitely want to have a mask or a respirator that's going to, a full face respirator. You're definitely going to want to Tyvek suit up. You're going to cover your skin, protect your lungs, protect your nasal cavities, and obviously you don't want to have any exposure at all. So the 3R's, what are the 3R's? The 3R's are what we call the recovery, recycling, and reuse of SF6 gas. And through this process, what we're doing is we're essentially recycling gas for immediate reuse on site. Essentially, we bring a recovery system. You recover the gas through filtration, capture it in cylinders, test, And depending on the end result, if you don't have to scrub it again, you can immediately reuse it. It's very important to note, though, that testing before handling and after handling is very important. This is going to give you basically a base of what you're dealing with. So if you have heavily arc gas, like I was mentioning before, or you have really wet gas, which can contribute to byproducts, you're going to be able to scrub that clean. You're going to be able to know that, hey, I need to put a certain number of pre-filters in place, or I need to scrub this gas a certain way so I can get it back to 100% reusable gas. Accountability. As I mentioned before, the EPA and some of the state level agencies require us to account for all the SF6. So accountability is really, really important when we're handling SF6 gas. That means looking at the pressure gauge or the density monitor versus the temperature of the gas. And what we use is a temperature curve or a gas correction curve that will tell us what the pressure should be depending on the temperature. And if we're low in pressure or high in pressure, that kind of gives us an idea if we need to make an adjustment. Or if, again, if we're low in pressure, that means we're losing gas, and that's something we need to take care of. So always verify the pressure versus the temperature correction or density temperature chart. Really important to know what you're dealing with right at that point and have good accountability. Key tools and resources, very important. Again, concentrating on the fact that it has a global warming potential that's very high. SF6 needs to be recovered 100%. So having the right size equipment is very important. If you have a larger piece of equipment that you're recovering gas from, you want to use a larger recovery system that can get down that blank off pressure, which is the maximum vacuum pressure you're going to leave once you recover 100% of the gas. If you use a much smaller recovery system with a large piece of equipment, a couple of things can happen. A, obviously, you're not going to be able to recover 100% of the gas. So for example, if I was only able to get down to like 0 PSI, I could leave anything between 14 to 18% of the SF6 gas still in the GIE, in the breaker. And that means when I open covers, that 14 to 18% is going to be emitted to the atmosphere. So that's why sizing your recovery system to the GIE, the volume of gas that you got to recover, is very important. Testing, so the analyzer on the far right there, you see, testing is super important. Like I mentioned before, you want to understand what you're dealing with. Are you dealing with gas that's highly arced? Are you dealing with SF6 that's got a lot of moisture? Or, hey, do I have SF6 that's immediately going to be able to reuse, which is a great factor towards eliminating further global emissions. I want to make sure I have the right recovery tanks or my storage tanks, my temp storage tanks. Do I have enough? For example, if you have a leak and you've got air introduction, air is not compressible like SF6 is, so you're going to need more tank space or more storage space. Fittings, a mass flow meter, and what we don't see here is a scale. Having fittings are very important that are self-sealing, that are not going to leak as you're recovering, so you don't, not only so you don't contaminate the gas, but also so you don't have any emissions. A mass flow meter or a scale to measure and account for all that gas, because we have to account for it in order to report it back to the EPA, and then filtration as needed. So when I perform my condition analysis of the SF6 gas, what am I looking at, or what am I looking for? Well, I'm looking for any non-reactive gases, meaning what's the purity of my SF6. And per the examples I'm giving here, an IEC specification and a SIGRE specification, we could see that there's different levels of acceptable purity. So generally, no more than 3% of non-reactive gases, other vapors, are allowable for in-use or in-service SF6 gas. Reactive gases like SO2, SOF2, HF, SOF4, any other reactive gases, those are those toxic components, those byproducts. You definitely want to be down at 0 ppmv. But if you have a piece of equipment in service, we will accept the fact that for reuse 12 ppmv is acceptable, and in service 500. Although many utilities will see 500 as an opportunity for them to go ahead and scrub that gas. Moisture, again, very important. Why? Because moisture is one of the contaminants that allows or interacts with arcing and may create reactive gases or byproduct. So anything down below 200 ppmv, which is pretty dry as it is right there, 200 ppmv of moisture is really good. Generally, what we see in new or reconditioned SF6 gas is about 100 ppmv, just to give you an idea. So how does handling work? So as you see, the far picture here on the right, that's a GIE, that's a gas insulated substation. If we were recovering, we're going to follow the orange line. We're going to go through the mass flow meter. Then we're going to go through our recovery system, and then eventually into a holding storage tank or recovery system. When we're filling, it would be the black line. We're going again through the mass flow meter, through the recovery system, and into the GIE. And then depending on what's going on, we use pre-filters where applicable, and we're going to put those pre-filters before the mass flow meter, so they would essentially go right here when we're recovering. We don't necessarily need pre-filters on the filling aspect of things, because generally we should be filling with clean or virgin or reconditioned SF6 gas. But again, make sure that we have the adequate training. Safety planning is very, very key to the success for the reuse of SF6 gas. So what's the perfect recovery? Remember, like I mentioned, if we don't recover 100% of the gas, we're going to leave some gas in the tank, and then that essentially can become an emission. So here in this example is, if I was to recover from 90 psig to 0 psig, I'm still going to leave about 14% of the gas in the GIE. So it's really important to get into that blank off pressure, that lowest of vacuum that I can achieve with that GIE. Again, having the right size recovery system is going to be very important to accomplish this. I mentioned filtration, so really important treatment of SF6 when you're recovering. We already know we have onboard filters, but having the combination of a pre-filter and the onboard filters is going to help us reduce moisture and eliminate byproducts. Remember that other toxins or other vapors are not able to be filtered. We go through the reconditioning process, and we'll discuss that after. I mentioned performing analysis, so really, really important. I already kind of hit on the different standards, but you want to be able to perform this testing before you do any handling and after you do the handling. Why? Because you want to make sure that you've taken that gas from whatever starting condition it's in, and it's been improved, and it's well within the spec for reuse. So the reconditioning process, like I mentioned earlier, back in November of 2002, a technical paper, a case study, was put together and presented at the International Conference on SF6 and the Environment. It was an EPA workshop that was held. And this technical paper and case study basically presented a program that analyzed a true life situation, a breaker that had failed. They recovered the gas, reclaimed it, they had to transport it, they performed a reconditioning process, and they were able to return it back into the supply stream. And what they were able to show is that you don't have to just rely on virgin SF6 gas, and it has a very positive impact on reduction of emissions. As this case study went on, what they did is they discovered a number of things. One, they realized that this breaker that failed, by the way, it failed initially when it was first energized. They were able to determine the arc that occurred, 44,000 amps for 20 minutes. That's amazing in regards to this. For those of you who know circuit breakers, that is a detrimental failure right there. They did mention that the ruptured disc burst, and this was an air insulated substation. In other words, it's an outdoor substation. However, they did say that they reported that they immediately recovered, and most likely this was one of those ruptured discs that blows open but resets, kind of like a spring set rupture disc. So the gas was recovered and evaluated, and they found that definitely had some high concentration of SO2, which already tells you that there's other byproduct in there. And they use a dragger tube method. So a dragger tube, they just force the gas through this dragger tube, and it changes color, lets you know that there's byproduct in the sample that was passed through the tube. Something they did is they stored it in nitrogen cylinders because they really didn't want to put them into SF6 cylinders and not have an issue there of cross-contamination. The failure was further investigated and the gas was analyzed, but the actual cause of the failure was never really determined. They sent the samples over to Germany. They received the samples and were able to see that, okay, this gas can definitely be reconditioned. We have the ability to process it, remove all the toxins, etc. So that's a very important piece when you're reconditioning SF6 gas, is again, understanding what are the components that are present, so I know that I can scrub this gas clean, and also especially when you have other vapors. So once it was received, like I mentioned, it was analyzed prior to processing. So they send a small sample first to determine whether they can do this, and then they sent the rest of the gas. And what they ended up having to do is they transferred the gas from those nitrogen cylinders into SF6 reuse cylinders. There's some shipping regulations that requires the right packaging, of course. They shipped it to Germany. The gas was processed and filled into tonners for return shipment. So they actually processed the gas in Germany, put it back into large tanks, those are tonners, and the reconditioned gas was put right into the supply stream. So there's a couple excerpts from the technical paper, but the big piece to get out of this is they discovered that it's definitely a viable program where we can basically eliminate the need to send the SF6 for destruction and have to reproduce SF6, or as I mentioned, create virgin SF6, because there's quite a bit of emissions created. So for every pound of SF6 taken back for reclaiming, and therefore it's not released to the atmosphere, is the equivalent to an emission savings of 22,500 pounds of CO2. Really important point in the conclusion of this technical paper. Again, what Solvay, AGA, and AEP did is they discovered that there can be a process where we can use SF6 gas and it meet the requirements of the standards for reuse in high voltage equipment. This is just a reference. So recently, a new document or an updated document, the 2019 refinement of the 2006 IPCC guidelines for national greenhouse gas inventories. It's a really important document to us because what it did is it looked at what the emissions are when virgin SF6 gas is manufactured versus what emissions are when you're reconditioning or recycling the 3R's process of SF6 gas. And as you can tell, and I'd really rather show this is the difference. So if we have 100 pounds of virgin SF6 gas produced, we can have an emission of 2 to 8 pounds for every 100 pounds of gas produced. However, when we're going through the recondition process, anything equal to or less than 0.64 pounds for every 100 pounds of gas reconditioned, and even less, 0.05 pounds or less for every 100 pounds of gas recycled. That's the 3R's when it's done. This is based on a 97% purity. For the reconditioned, 95% purity. We're bringing the reconditioned process back up to, or the purity process to 99%. So really has a very positive impact when either you recondition SF6 or you put it through the 3R's process. We are eliminating emissions to the atmosphere globally by hundreds and hundreds of pounds at a time, but thousands and thousands of pounds globally when we're reusing SF6 gas. So really an important point to consider whether you're reusing it or you're reconditioning or recycling. And again, you can find more information out. Here's the link. I know we're going to share our slides, so please feel free to check it out. It's got some great information in regards to emission reduction plans. So what is the reconditioning process? So it's first, again, we always analyze. Analyze is very important. So we bring in the cylinders. We also do accountability. We got to weigh that gas and understand how much we're dealing with, because we don't want to lose any of this gas through this process because of emission reduction. We put it through the reconditioning process, which is a cryogenic process. We go from minus 20 degrees C to minus 30 degrees C to minus 40 degrees C. We also increase the pressure to about 720 to 760 PSI, and that liquefies the SF6. All the other remaining vapors, which is going to be air or nitrogen, we can just release that to the atmosphere and not worry about any major emission loss, but then that purifies the SF6. We then reweigh and retest the SF6 gas. Once we're satisfied with the results, we just account for it, boom, introduce it back into the supply stream. Really simple. Again, I've talked about this, the standards. So when we recondition SF6 gas, I have a couple examples here of what that means. So we're taking gas that has a really low purity, and we're hitting some great purity levels, anything better than 99% purity. In some cases, we're even hitting 100%. Our moisture well below the 200 ppmv mark. In this case, we were hitting less than 40 ppmv. And again, so when we report out, we know that we have the ability to improve that gas so it can be immediately reused in the field, just as good as virgin SF6 gas. As I mentioned, accountability is really important. Each cylinder has to be weighed and analyzed. That's for EPA reporting purposes and really important. So the cylinders are tagged with the cylinder serial number, the tare weight, the gross weight, and the condition of the gas. And that helps the receiving party account for their reporting that they have to send to the EPA or their state level agency. So SF6 is definitely a proven arc quenching medium. We've known this for years. When subject to high temperatures of arcing events, unwanted byproducts are introduced. Improper handling techniques and exposure may contribute to further contamination of the gas. But always know that SF6 is 100% recyclable. It's really important to understand that, and it will meet the industry standards for reuse in gas insulated equipment. Recycling technology, we're always making improvements in this field, and we're getting excellent results with zero emissions. Remember that the reuse of SF6 contributes to the reduction of greenhouse gases, which is very important. That's what we're trying to accomplish, is how do we reduce our greenhouse gas emissions? So in conclusion, new alternatives, I want to mention this really quick. New alternatives are definitely coming out. There's some excellent benefits. Obviously, lowering the global warming potential is one of them. We're still learning about them. We're still working through it. We're prepared. The industry itself is getting ramped up to it. There are reporting processes behind it as well. States like California are already looking at regulation in forcing SF6 to be minimalized and new alternatives being introduced only into the state. We'll continue to make those improvements as an industry, and as alternatives improve, decisions will be made as to what we should use. But however, SF6 gas will still continue to be one of our most important mediums for GIE insulation. So we need to make sure that we're reducing those emissions by using the recycling processes, the 3R's, and also reconditioning. Training, knowledge, continuous training is very important. Handling techniques, knowing how to deal with SF6 gas in the field so you do not create emissions and so you do not contaminate SF6 gas is very important to also reduce the emissions. That's what I have. Do we have any questions?
If you have a question, please ask your question of Billy.
I wanted to ask you about that. In India, people are not that much aware of greenhouse gases emission. We are openly using SF6 gases without any further jurisdiction or like under any supervision. So how can you throw this knowledge into countries like India, where people are not aware that what is the long-term usage effects of SF6.
So if I understand the question is how do we introduce that further into countries that are not practicing?
Yeah.
Right. Okay. Well, I mean, to us, it's here in the United States. I could say it this way, and we have in much smaller examples, we have those issues where it's not being practiced well, and it's training. It's continuous forums such as this one where we can spread the word and let people know that the impact on global emissions is really bad. So for example, for every 1 pound of SF6 emitted to the atmosphere is the equivalent of letting a car run for 365 days in New York City, for example, in a taxi in New York City. Trying to get that word out is the best, to me, the best way. The other thing is showing that there's tools out there that we can use to reduce emissions during gas handling.
Thank you. I got the point you want.
Thank you. Appreciate your question.